patterns right here. The arithmetic either goes up or down by the same amount. Now, today we're going to start doing is looking at a little different stuff today. And instead of looking at arithmetic sequences and series, we're going to start looking at what here? Geometric sequences and series, okay? Going to be rules just to plug stuff in. It's going to be very similar to the last section. It's just going to be a different type of pattern that you're going to see today, okay? So question to answer today. How can you recognize a geometric sequence from its graph? Okay, not going to get too excited about the graphing. We are going to make some connections with the way the graph's set up for a geometric sequence. So here we go. Goals today, kids. First of all, we have to be able to do what? We got to be able to see a sequence and say, is that geometric or not? Okay. We're going to write rules for geometric sequences. So we're going to have a of n is equal to something again. And then we're going to find some what? Sums of finite geometric series. Means there's going to be a first term and a last term. Okay. All right. So what the heck is a geometric sequence? Let's talk. Okay. Take a look at this pattern over here, friends. See a pattern in here?
Yep.
What happens each time? Yeah, 1 to 4 to 16 to 64, you're always timesing by 4. Now, we'll talk about how we get that. But guys, definition of a geometric sequence is an ordered list of numbers in which the ratio between each pair of consecutive numbers is the same. I know they look at that by going by 4, but here's what I want you to think about. Geometric sequences, I want you to kind of think of division. Okay? And let me tell you why division. I'm going to draw some arrows up here. Okay? We kind of did this in 7.1 a little bit, identifying the patterns. But guys, what's 4 divided by 1 right here? What's 16 divided by 4? What's 64 divided by 16? If I asked you to figure out the next term in that sequence, could you do it?
Yeah.
What would you do?
Times by 4.
Times what by 4?
64.
64 by 4, right? You get to 56, eh?
8.
Okay?
Hey. Oh, yeah, you wait.
All right. So we're kind of looking at division. So now the next term here is not common difference anymore. It says common what? Okay. Common ratio is the constant ratio R between consecutive terms of a geometric sequence. Above, right up here, kids. Above, what's the common ratio? What were we constantly multiplying the
4.
previous term by to get the next? 4. So above, the common ratio is 4. Okay. Then guys, a geometric sequence is a list of common ratios. Then a geometric series is the expression formed by doing what? Adding the terms of the geometric sequence, okay? If I wanted to know what this sum was right here, I would take 1 plus 4 plus 16 plus what? 64. Okay, do you think there's going to be some rules for that or some formulas for that? Okay, maybe a Krabby Patty formula will be in there, okay? But a geometric series is simply going to be the expression formed by adding the terms of a geometric sequence, okay? Guys, exponential function is a function that takes on the form y is equal to a times b to the x power. Things you're going to hear me talk about with exponentials. You're going to hear me talk about graphs that do this. They show exponential growth or exponential, anybody know the other word? Decay. Okay, those are the types of graphs we're going to get with geometric sequences. All right, growth and decay. And then we'll talk about some properties of exponents as we move through here. Okay, not too worried about this right here. I think you'll understand what's happening here as we move through this. All right? Okay, my friends. Vocab-wise, how you feeling right now?
Good.
Understand that we're not looking for a common difference. How much we're adding or subtracting anymore. We're looking for a common ratio. And how much we either add, multiply, or divide by, right? I have a question. I can multiply like 4, right?
Right.
If I divide 4, what's that the same as multiplying by? 1/4. Okay, so think of reciprocals in this, all right? Guys, first one right here says tell whether the sequence is what? Okay, here's how you do this, kids. First one and second one. Second one's going to be kind of tricky. Okay? First one right here, the way I would start is I would take negative 18 and divide it by negative 3. Okay, you're always dividing when you check and working from one to the previous one. What's negative 18 divided by negative 3?
6.
Okay, next one. Negative 108 divided by negative 18.
6.
Is that 6 also? Okay. All right. What's negative 648 divided by negative 108?
6.
Somebody do negative 3888 divided by negative 648.
Got you.
6.
Okay, so what's true about the ratios that we get each time? Okay, now I want to talk about this right here. Okay, since the ratios are the same, this shows this is. I'm going to write since ratios all equal what?
6.
Is this a geometric sequence?
Yep.
Okay, now here's the deal. Suppose I was paying you guys money. And if I do win the lottery this weekend, you'll get your 100,000.
Oh, okay, that's a verbal agreement. I need my 100,000.
I've
Said
said
if he
it.
did.
Wait, he's knowing it.
If I did, okay?
When you do.
I hope I do. Trust me, I hope I do. I'd love to give you guys all $100,000.
Then
You
you
can
can
quit your job and just do
Oh, yes.
whatever you want for the
I'd be long gone. I'd buy my contract and be long gone. Okay, you probably never see me again.
You do that every NASCAR race.
I would be. Okay, come visit me there.
You would
All right.
live at the
You'd
NASCAR track.
sponsor NASCAR car.
It's good stuff.
You'd sponsor one. Yeah,
What do you
that's
call it?
I
A
could probably buy
sponsor
a team.
NASCAR or a NASCAR car? How do you say that?
NASCAR stock car.
Wow.
NASCAR stands for National Association of Stock Car Auto Racing.
Okay.
Okay.
Never knew that.
Kids, would this be an example of exponential growth or decay? We're multiplying by 6, so are we making numbers bigger or smaller?
Smaller.
Bigger, right? This sequence, okay? But think about this right here. Is this going to be growth or decay? What's your common ratio? Bigger than 1, right? Okay, so we'll talk about that as we move forward here, all right? Now, this next one is not so much fun, okay? We have to take 3/4 and divide it by what here, kids? Okay, when we start dealing with fractions right here, my suggestion here, when you have like 3/4 over 1/2, division by fraction is the same as multiplying by the. So do you guys agree that this one would really be 3/4 times 2 over 1/1? Okay, help me out here, kids. What's 3 times 2 up top? 6 over 4. 6 over 4 gets us 1.5. Okay, so the first ratio is 1.5 here. Okay. Now I need to check 5/6 times what, kids? Okay, so if I'm taking 5/6 divide 3/4, that's like 5/6 times what, kids? 4 over what? 3 here, the reciprocal, right? Guys, help me out. What's up top here? 20. What's on the bottom? That's a weird looking 6. Somebody take 20 divided by 18 for me. 1.1 repeating. Hey, quick question right here. How about your ratios? Are those two ratio values we got, 1.5 and 1.1 repeating the same? Is there any sense in checking anymore?
No.
Once the common ratios don't agree with each other, everything's falling apart. Is this geometric or not geometric? This is not geometric, okay? And what's your reasoning for it? Common ratios are not the same. So this is not geometric. Okay. Anybody see a pattern for that though?
No.
The bottom times by 3.
Bottom keeps getting multiplied by 2.
It's up by 2.
Yeah.
So does the top. Crazy.
Yep, you're right.
You.
right, kiddos, are we good there?
Yep.
Ready for next page? Good? Alright, let's chat, kiddos. So core concept, this is going to be a pretty important one for you again here, I think, okay? It says rule for a geometric sequence is the following. It says the nth term of a geometric sequence with first term A1 and common ratio R is given by, what's the formula down here, kids? Nth term equals the first term times, what do you think R stands for? Common ratio to the what power here?
N minus one.
So as an example here, suppose right here, suppose the first term is 7 and R is equal to, say, maybe 5. Okay, write a rule for the nth term here, kids. What would it be? What would take the place of the first term right here? 7 times 5 to the n minus 1 power. Okay. All right. I need to run something by you quickly today. All right, to make sure we remember this. If I had, and this kind of goes back to your properties of exponents. If I had like x to the 20th power over x to the 6th power. Guys, I have a question. How many x's are really up top here then when I write that exponential like that? 20, and how many x's are on the bottom? So wouldn't 6 x's on the bottom take 6 x's out on the top? So in simplest form, what would this become? X to the 14th. What do you do with the exponents when there's division like this with common bases? Yeah, this is the same as x to the 20 minus 6, right? Which would equal x to what power in simplest form? Okay, remember that because that's going to show up. All right, just remember that because that's going to show up. All right. Okay, here we go. Writing a rule for what, kids?
Can you go back? Well, wait, I'll write that down. Alright.
Anybody else some more time? All good? All right. So kiddos, let's talk right here. Writing a rule for the nth term. Here's the deal. I should maybe write this down here. In order to write a rule for the geometric sequence, you need to know what the first term is and what else?
Oh, the ratio.
Common ratio. We gotta have a value for A1 and we gotta have a value for R in this, okay? Well guys, take a look at number 2 here. Okay, this says write a rule for the nth term of the sequence, then find the 10th term. All right, let's talk right here. Kids, oh boy, the rule, I'm going to write it down again. The nth term in a geometric sequence equals the first term times the common ratio R to the n minus 1. Okay, do we know what the first term is, kids?
Yes.
Yeah, A1 is equal to what here, kids?
6.
Right?
Yeah.
Okay, do we know the common ratio R? This is the part where I get worried. Okay, do 2 divided by what here, kids? 2 divided by 6. That's like 2 over 6, isn't it? What's 2 over 6 reduced to? Okay, so the ratio is 1/3. Makes sense that my values are dropping, doesn't it?
Yeah.
Okay, what's 2/3 divided by 2? Or in other words, 2/3 times 1/2.
1/3.
1/3 again, isn't it? Yeah, I just want to make sense here. Again, if we start running into fractions like, okay, 2/3 divided by 2, if I would do the 2/3 divided by 2, that's the same as 2/3 times the reciprocal, isn't it? What do the 2's do to each other? Leaving you with what common ratio? Kids, do we have the first term?
Yeah.
Do we have the ratio?
Mhm.
If I want to write a geometric rule for the 10th term or for the nth term, a of n would equal what here, kids? 6 times 1/3 to the, they typically put that ratio in parentheses like that, to the n minus 1 power. Okay? Now, what are we trying to evaluate, kids? The 10th term. Now, this is going to be pretty ridiculous here that they did this to us on this, because 1/3 to the 9th power is going to be astronomical. It's going to be really close to 0. But here's how you would handle this, kids. Order of operations would say to do this. Wouldn't this equal 6 times 1/3 to the what power now? Or 10 minus 1, right? Okay, now notice I put my fraction in what, kids? Okay, your calculator can help you do this, all right? So go to, you're going to get something really ugly on this, and I'm sorry about this. But if you type 1/3 in parentheses go 1 divided by 3, in parentheses, and raise that to what power?
Whoa.
You gotta raise that to the 9th. You guys agree that I gotta do the power before I can multiply by 6, right? Order of operations would say do powers first, wouldn't it? Okay, so you're gonna do 1/3 in parentheses, all the what power first? 9th, and then times that by what? 6. What do you get?
Long number.
0.0003. How many zeros, Lauren?
3 zeros.
So 3 tenths, hundreds, thousands, 3 10,000s?
Wow.
3 10,000s. That's about how good I was in English. That was my percent in English classes when I was in high school.
Really?
Me English ain't so great.
I don't believe it.
Me was kind of not very good at English. Me wasn't good at English.
You weren't good at English?
Me wasn't.
Still are.
I seen a book one time that thought it could help me, but I didn't buy it. Ain't that a bummer?
Oh, that's funny. That was a good one. That was actually a good one.
You
Why
guys
did
do
you
the
laugh
next
at
one,
that? That
okay?
was-
You guys do the next one. 10th term and find the 10th term. This one should be pretty easy. This one you'll like. All right, friends, what's my first term?
10.
So what's your common ratio?
2.
We all agree 20 divided by 10 would be 2.
Yeah.
40 divided by 22.
Yeah.
This is a little nicer to work with, isn't it? Okay, so what's that make the nth term in terms of a geometric rule here? 10 times what? 2 to the, okay, 10 times 2 to the n minus 1. Okay, what are you plugging in for n?
9. Or 10.
So we're really going 2 to the what?
9.
2 to the 9th power first, and then times 10. This would be a pretty sizable number. 5,120?
Yeah.
Somebody give me a show of hands, some confirmation on that. 10th term, 5,120? Okay, all agree with that? Okay. You got the formula kind of memorized already? Nth term equals the first term times the common ratio to the n minus 1 power. Okay, let's see what we can come up with here. So again, we said what 2 things do you have to be able to write a rule for? First term and common ratio here, all right? Well, good. Writing a rule given what here, kids? Okay, this time, kids, they give you what term?
85.
Okay, so the 5th term is What? Do we know the first term this time? Would you guys agree right here that the fifth term, A5, would equal my first term times R to the n minus 1? Of all the variables up there, what can we plug in for?
The N,
The n would be what value?
5.
So we can find a value for n. We know we're dealing with the fifth term, right? What else could I plug in? R, because that's the what? Common ratio. What else could I put in up here? Fifth term, A5. We know that. So what don't we know up here we're going to have to solve for to be able to write a rule for the nth term? Okay, so let's plug our values in. What's taking the place of A5 here, friends?
32.
Equals. Okay, so 2/3 to the. Okay, so we would go, let's see, wouldn't this be 5 minus 1 here, friends? Okay, so in your calculator, here's how you want to do this. When you type this in your calculator, you're going to go parentheses 2 divided by what? Raise that to what power here? Fourth power. Okay, you're going to get a decimal. I don't know what that decimal is. Well, I do, but you guys tell me.
0.1975.
0.1975 times A1 is equal to what value? Now kids, I want you to ask yourself about this ratio right here. This ratio, we're multiplying previous values by 2/3. We're taking 2/3 of values. So is my sequence going to be a list that's getting larger as we move up the list, or getting smaller? Has to be getting smaller. So if the fifth term is 32, wouldn't it make sense that the previous 4 terms would be bigger than 32? Okay, how are you going to solve for A1 right here, kids? So 32 divided by 0.1975, 9 there. Hey, 1975, what a great year for people to be born. Oh my gosh.
Were you born then?
Yeah,
I was born actually.
46 years old, 1975, January
My
6th.
dad's older than you?
Wait, when's your birthday?
Hopefully your dad's older than me.
Is he
Why were you
older than your dad?
Because.
You telling me he looks old?
No, I just like.
Yeah, dude.
Kind of what it sounds like.
That's not what I meant. No, this quality Ted teach my dad. So,
Oh,
like,
Oh my
sorry,
God.
guys.
English is running off really?
So then I was like, I don't know, I just kind of like didn't really think of it.
I didn't teach your dad.
I didn't even know Ruby was your daughter until this year.
Yeah? Do you like Ruby?
Yeah, I mean, I didn't talk too much.
She's a pretty quiet kid.
He is really quiet.
Yeah.
Is that a bank?
Alright, kiddos. So what did you guys get when you divided?
162.
I mean, I know my hairline kind of gives me away age-wise, but after that, I don't think I look all that old. Maybe I do.
God, Dave, you're making him feel bad.
Stop, I don't think he looks old.
I'm gonna go buy a cane this weekend. I'm gonna go find the coolest cane that I can in Chicago this weekend.
Just
Okay?
go all out and get one of those little carts.
Yes, I
people
have to
sit
go to
in.
Chicago tonight.
For what? Yeah, for what?
My middle daughter is in a swim camp for the weekend, a footwear class for swim camp. So she gets to go swim and I get to go eat pizza and go shopping. Sounded like a pretty good deal.
That's a win-win right there.
Wait, how old are your daughters?
Lucy is the one going. She's man, how old is she now? 12. Okay. All right, we got to write a rule for the nth term, kids.
Yep.
Ruby's not in high school. That's not possible.
She's in 8th grade?
Yeah.
I didn't know that.
Okay.
She's almost graduated.
I know.
Going to 2.
Makes me sad.
Don't.
All right, what's the first term?
160.
I'll never forget the day I carried her out in my arm from the delivery room all by
Oh,
myself.
that's sweet.
Yep.
How do we have to make him cry?
Good stuff.
got sentimental real quick.
Oh, I do. I'm a softie. I'm a softie.
Good to know. Me too.
No, she's not. She's the devil. Ah!
All agree right there?
Not true. Not true. Yeah. We agree.
Yeah, we.
Okay, let me see what we've got here next, all right?
break.
Again, was I able to figure out what A1 was?
Yes.
I would strongly encourage you to just write the formula down every time. Fill in what you can, work on finding your stuff and working with it, okay?
This is gonna be a hard one.
I would like to get through example number, what are we on, 3 right now or 4?
4.
I would really like to get through example 4.
Okay. Okay, I can do that. Me too.
4. Okay.
No, this one is hard.
Example
How do you
4.
know? You haven't done it yet.
Example
Because
4,
it's
we'll
the
call it a day, all right?
No, we didn't.
So here's the deal. This is kind of like the one that we were asking about with the arithmetic sequences and saying, hey, one term is this, another term is this, write a rule for it, okay? We said to start with the 1 further up the list. So which terms are we talking about in this geometric sequence, kids? So we're starting with the 3rd one and the 6th one, right? So let's just start with this 6th term. I'm going to say, okay, we know we're dealing with a 6th term. I'm going to write, we know A6 is going to equal the 1st term times a common ratio to the n minus 1. And we also know, friends, that we're dealing with what other term? That, my friends, is going to equal the 1st term in the sequence times the same common ratio to the n minus 1 power. Okay. You guys agree with what we've got there so far? Okay. Well, kids, let's just take a look at this first equation right up here. Do we know what the 6th term is? Negative 160. You got it. So we're going to call this negative 160.
See, this is where it's hard.
A1.
Okay. Do we know the 1st term?
No.
Don't have a clue. Do we know the common ratio?
Yeah.
Don't have a clue, do we? Okay, but what about the n value here for the 6th term?
6.
So this is going to become 6 minus 1 up here, so won't this become a 5?
Yep.
Okay, you agree with that?
Yes.
Okay. Let's do this for the 3rd term. What is the 3rd term, kids? Okay, here's where things get kind of interesting. Now guys, in the last section when we talked about arithmetic sequences, we said take those 2 lines and do what with them? Subtract. But we were using subtraction because arithmetic meant you add the same amount each time, and the opposite of addition was? This time, my friends, we're not talking about adding the same amount. We're talking about, in a sequence, multiplying one value to get to the next. So instead of subtracting the 2, what do you think we're going to do? We're doing the inverse of multiplication right here. So we would say this, if negative 160 is equal to this mess on the right, and 20 equals this mess on the right, wouldn't negative 160 over 20 be the same as this divided by this?
Yeah.
Okay, well what is negative 160 divided by 20? Okay? Now kids, when I divide on the right side, what are the a's actually going to do to each other?
Cancel.
Okay, and this is where these properties of exponents come into play. How about R5 over R2?
R3.
Okay. 2 r's on the bottom will take 2 r's. Now, we're at this point, r to the 3rd is equal to negative 8. What root do I need to take of negative 8 to get my common ratio? Yeah, I need to take the cube root now, don't I?
Yeah, I read you.
Okay, what number times itself 3 times would make negative 2?
You just said it negative.
Ah,
Right.
what number times itself 3 times would make negative 8 is what I meant to say.
Negative 2.
Yeah, you guys are on top of it. I love it. Okay, not a long week for this old man.
Starting to call himself old.
Stop! Missy.
He would have called himself young man yesterday.
Did I?
Yep.
I'll find the Fountain of Youth this weekend somewhere.
In Chicago.
Yeah, maybe it's there. Okay, so guys, we know the common ratio now. That's good, right?
Yep.
What else do we need to set out to find?
A1.
Oh, I thought we were looking for the Fountain of Youth. Okay, we'll find A1. Okay, so what do you think I'm going to do then, kids?
Plug R back in.
Yeah, once I know this right here, can't we jump up to one of these equations here now?
Yep.
Yeah.
Okay, I'm going to jump right back up to, let's do the r squared one. Let's work with smaller numbers. Is that all right?
Mm-hmm.
Okay, so this thing is getting laggy and I don't know why.
Getting old.
Yeah.
Screw that.
No.
I thought it was probably the operator. Okay.
Finishing, I think.
So, you know r is -2, don't you?
Yes.
So right here, kids, I'll make some room here a little bit. I'm going to have, if I'm lucky, I'm going to use this one right here, this 20 right here. This 20 could equal A times, okay, what's going in for R here, kids? This thing has gotten slow and I don't know why.
Whoa.
-2 to what power here? What power was up here in this line? Okay, well, what is -2 squared, kids? 4. Okay, so degree 20 is equal to 4 times A, really A1. That's what I should have put here. Okay, so you talk to me. What's that make your first term? 5, doesn't it? Okay, so we're going to divide both sides by 4. And the first term would equal 5. Kids, have I accomplished the first term here? Have I accomplished a common ratio here?
Yeah.
So with all the work over here, what's our nth term going to be? I'll write it over here. I know it's not very organized here today, but so the nth term here would be
A of x equals 5 times -2 to x minus 1.
okay. What do you guys think?
Good.
We'll probably visit this right away again. This example probably right away again, or something similar to it on Monday.